So exhibit A in all of this is that when I go to select pulse or double pulse MIG, gives me a warning saying I need enough voltage. And then I say, yeah, it's carbon steel. And it says, great, you can use C8 or C10. I say, oh yeah, I have that. And it gives me here's my wire thickness. And now I'm all set up, except that I don't have C8 or C10. And what I do have though, is a full tank of argon and a full tank of C25. And I have a argon flow meter here in CFH, and my MIG regulator has mixed gas CFH that I can set. So the idea here is I should be able to hook these suckers up and mix the gas myself. Yeah, so I called a couple different places, and I imagine that there'd be a way to hook two tanks to one line, some kind of manifold, and indeed people make them, but they're hundreds of dollars. And then you can buy a proprietary gas mixer, and those are also hundreds and hundreds of dollars, even a Chinese one. So what I decided is I need a new 6-foot gas line that would go from one of the regulators to the machine, to the MIG port, and then I would get a double male hose, a short one. And then what I can do is I can run the male between the two Ys. The Ys go to the regulator. My current hose comes out here and goes to the argon, and the new hose comes out here and goes to the MIG. And that way, you know, if I open the C25 and nothing else, then I get C25. If I open C25 and I open the argon, then I can mix argon into the C25 to dilute the CO2 in the C25. And I think there's something called Dayton's law that you use with flow rate. It'll tell you how much, what your CFH should be, the ratio of the CFH. And what I got here, these are made by, supposed to be made by like Western Enterprises, I think. This says Weldmark. They're supposed to be made in the US. And they were, I think they were $40 each. So yeah, we'll give it a go. It's nice they have valves on them. All right, now I cleared something up. So Weldmark repackages someone else's stuff. And in this case, it's from Superior Products. I thought I was buying something from Western Enterprises, but it turns out Superior Products, also in Ohio, makes a very similar thing. So this is supposed to be just as good as the Western Enterprises, so no concern there. All right, so here's the concept. I got these valves here that can all be shut off, and they handle up to 200 psi, which is way more than I'll ever be seeing out of my flow meter. And then I've got, so if this was hooked up to argon, I open this one and I'm feeding argon to the argon input on the TIG. And I close this, I open this one, I'm now feeding argon into this Y joint. This is hooked up to the mixed gas, C25. C25 coming in here, argon coming in here, and so some combination is going to be coming out on this one and going to the input for the MIG. All right, and here we are, argon bottle, the Y. Here's the hose that goes to the mixed gas Y. Hose comes down and goes to the mixed gas is here, TIG is here, and versa versa. So Yeah, pretty simple.
Okay, here's a little presentation I made to describe gas mixing at home. Stuff you'll need is obviously a pair of gas tanks, one of them richer than your target mix and the other leaner. You need flow regulators, you need Y joints, preferably with shutoffs, and you need more hoses to connect everything. Here's the layout that I used. Um, and you can see there's a connection line between the two tanks, and then one hose each to the MIG and the TIG inputs. So for TIG mode, everything's shut off except the argon tank and the Y output to the TIG argon input. And this just sends argon to the TIG input. So here in C25 mode with a C25 tank, everything's shut off except the C25 tank and the Y output to the MIG gas input. And then here's the mixed gas mode. The argon and C25 tanks are turned on. The output from the Y joint argon tank is open. The Y joint the other way on the C25 is open. And the Y joint output from C25 to the MIG is open. And you'll see the argon is flowing to the Y joint, and the mixing occurs at the Y joint and at the hose between the C25 and the MIG gas input. And okay, so with flow regulation, uh, first of all, you can't mix gas using pressure regulation. Um, I mean, it might be possible, but it's really finicky because the output pressure of one affects the flow of the other. So you'd have to balance the pressures. And I don't think there's enough accuracy on a pressure meter to do it. So anyway, what I've used is flow regulators. And the important thing is if you have one of those floaty ball rotometers, those are showing you the physical gas flow. And so those work. And the other is if you had a back pressure compensating flow regulator. And my Victor does that, where it'll tolerate pressure in the output line and still output the desired amount of gas flow. I think it's set up to 150 psi back pressure. So the math. Um, so the key here is that we're modeling the carbon or the CO2 in the gases. We don't need to pay attention to anything else. And the idea is that the output mix times the flow total equals the tank one mix times tank one's flow plus tank two mix times tank two's flow. And if you know your mixes, you can just plug the numbers in. And this is a simple case of C25 and argon. The argon CO2 mix is 0, so that cancels out. And then we left with flow of tank 1 is the ratio of the desired mix divided by the C25 mix. So we take that flow total times target mix over C25 mix. We know our total flow is 20 CFH. So we multiply by the ratio, we end up with 6.4 CFH. And then the remainder is going to come from the argon tank, which is 13.6 CFH. Generally, in the math, you can, if let's say you didn't have argon as your second tank, then we'd say you have a rich tank and a lean tank. And the math still works out pretty simply. The fraction of rich gas is the target mix minus the lean mix divided by the rich mix minus the lean mix. So for example, with C25 and argon, we end up with 0.32, which is the same as what we saw before. In the case of trying to mix C8 using C25 and C10, this tells you that you need 11.8% of your gas flow to come from the rich tank and the remainder from the lean tank.
Okay, and after all that math, so here I have the back pressure compensated Victor flow meter, and here I have a normal Rota gauge, and you'll see that the flow right now is showing some really high number. What is it, like almost 20? And this guy's at 0. And that's because there's back pressure right now. But once the flow happens, you're going to see that this thing drops down to where it's supposed to be. So here I'm hitting the purge button, and we'll see the ball valve go up and the flow go down. Right? And so the flow is at 6 and the ball valve is showing about 16. Another test to see that the back compensation's working. Here I have this valve turned off from the argon, and no gas is flowing right now. I'm going to turn on the purge, and then I'm going to cycle this valve on and off, and you'll see that this flow gauge reading doesn't change. So hit the purge, click, and then I open, close, open, close, open, close, open, close, open, close. And what that means is that the back compensation is working on this back compensation Victor flow meter. Gave the old pulse stitch welding a try and realized that I hadn't read my units correctly. The CFH is on the inside of the dial there, so I had to set it really low, had it set it below the 10, and then I set this guy up so that I had the right ratio. It's basically 2 to 1. Once I did that, I started making a bunch of little spots on here, and I played around with the settings until I got it to wet out. That's what I'm looking for. And then I made this little, see, that looks terrible, but made this little cube out of 24 gauge. And you know, when it goes well, it goes real well. And then when it goes bad, then, you know, sometimes the arc doesn't start, and then it kind of sends a piece of wire in there, and then the arc starts later, and it's kind of unreliable, at least for me right now. But this is a cute little thing, and you know, I didn't burn through. I think I missed a spot right in there, I guess. No, I don't know. It's pretty cool. I mean, you know, fits on my hand. This is this thin little piece of 24 gauge. So yeah. So, you know, I think the gas definitely makes a difference. When I had the gas wrong, it was making all kinds of blobs, nasty stuff. The thing I found, I turned the voltage down by 1 volt and left it, you know, it's still synergic, but I dropped the voltage. And I'm kind of in the upper end of the 24 gauge, and I'm using the pulse spot. You can see it says spot in the corner here. And that's, you know, for this stuff, you can't really weld continuously, or at least I can't. I don't know how to do that. Because it really wants to burn through. Maybe it'd work, I don't know. But this is my first little thingy. So, all right. Anyway, I hope you enjoyed the video. Bye.